Unit 0, Lesson 4, Measurement. With science, we have to be able to measure, and as review, we talked about accuracy and precision, but we're going to talk about it again here when we're talking about measurement. And so you should be filling out your guided notes as we go along. And so your guided notes should look like, if I can pick up the app, should look like this. And so there at the top, you can see you have a place to put in accuracy and precision. So accuracy is how close we get to a known or accepted value. If I measured volume by using this cup and using English units, I might measure 1.5 cups of coffee. Versus if I use metric units, if I use a 100 milliliter graduated cylinder, I could get close to about 1 milliliter. And so I could measure it to maybe 78 milliliters are left. Okay? But if I used a smaller increment graduated cylinder, let's say I used a 25 milliliter graduated cylinder, I can measure to even closer to what the real measurement is. So I would fill it up to the 25 mark, and I would have to pour that out, and then measure again 25, pour that, measure again 25, and then I would see where it would fall on that last graduated cylinder. And I could measure probably to the tenths. So now going from about 78 milliliters, now I'm at 77.2 milliliters. And so accuracy is how close can we get, or how close can we measure to the true value of what we're measuring. Precision. How close are measurements to each other? So if I had a graduated cylinder and I was measuring a volume and I measured 48 milliliters, and then I asked you to measure it and you measured 52 milliliters, that's not very precise. But if I did the experiment again and I measured 48 milliliters and you measured it again, this time you measured 48.5 milliliters, that's more precise. Our measurements are closer to each other. We use scientific tools to help us be more accurate and precise, like a ruler, a triple beam balance. I'm a graduated cylinder. So here's some examples that aren't the bullseye example. Usually when you talk about accuracy and precision, you see a bullseye example with the arrows. Here's a number line instead. And so in the center is where the true value of what you're measuring is. And so you can see in example A that we have the red dots all close together in one spot, but it's not where the true value is. So it's not very accurate, but the measurements are very precise, meaning the measurements are very close to each other. In sample B, those measurements are more accurate than sample A, but they're not very precise because the measurements are very apart from each other. In sample C, not accurate and not precise either. And then in sample D, we have the cluster of measurements around the true value, which would make it accurate, and all the measurements are close together, which would make it precise. These are two words that you really have to have a conceptual understanding of as we're going through science and taking measurements in our labs. In everyday life, we don't always use SI units. We can use ounces and pounds and inches. Those are more or less called the English measurements. In science, we use SI units, standard international units, and that's to ensure that everyone is using the same thing and we're not making mistakes. So if I'm measuring a heart valve in Georgia and I measure it as 1.2 nanometers, and someone in England is measuring it as 0.0005 inches, we could not be having the same measurement. And that would be a problem if we tried to actually use that mechanical heart that we were making. So we use SI units to make sure that everybody is measuring the same way. It helps us reduce mistakes, especially nowadays when we are building things in manufacturing where one part may be built in the US and we might have to ship another part from another country. So those two parts have to be made using the same units. So common SI units that you'll see are here on the slide. The table that's in your guided notes is on the next slide. So these are some examples. When it says Kelvin for temperature and it says thermodynamic, we're used to seeing temperature in Celsius or Fahrenheit. That's Earth temperatures, what we are exposed to. But if we're trying to measure something that's way hotter, like the inside of a star, we need to use kelvins. Because we're talking about temperatures that do not fit on our scales of Celsius and Fahrenheit. So some common SI units that we're going to use in lab. You'll see these as we go through. When we go through force and work, we'll be using the formulas for those. And we have some base units for those SI units. So when we're measuring mass, we're going to use grams. We could be looking at a kilogram, a milligram, a centigram, but the base unit is going to be a gram. When we're measuring length, it's going to be the base of a meter. So we can measure things in millimeters and centimeters, hectometers, decameters. Same thing with volume, we're using liters, and time we're using seconds. You could have centiseconds and kiloseconds. The first part of lesson 4 is going to be about measuring length. And we measure length using rulers usually. And now that we're in science, we're going to use metric units, not inches. There are 2.54 centimeters in 1 inch. So when you're measuring in science, you want to make sure that you're using the other side of the ruler, the one that has the millimeters and the centimeters on it. In science, we also have tools that are more accurate in that we have what are called calipers. And maybe I'll try to bring some of those in when you're doing this lab so that you can see them. A guitar is considered to be about 1 meter, if you wanted to think about something that was about a meter. In Puzzle, there's a video for you to help you grasp these concepts. You don't have to watch it, it's not required, but it is there for you as a resource. And your first part of this 2.4, besides the guided notes, is to do the ruler game. So in the ruler game, you're going to finish it, and then you're going to snapshot your results and put it into GoFormative. So here's what the ruler game looks like. You want to make sure that you're doing the metric ruler, and you hit play game. And so you have to put the cursor where the measurement would be. And it times you also. So at the end, you're going to see what level you can get up to in a certain amount of time. And you only get 3 strikes. So see, I just got a strike. And so as you go along, you move up letters and you only have so much time. And what you're going to do, you're going to screenshot your results. Now, if you have a PC, it's going to be different taking a screenshot than it would be if you have a Macintosh. And in the GoFormative, it helps you, it gives you a help page on how to take screenshots. So here you have an example. Oh no, this is volume, sorry. Sorry. Well, okay. This one should be on the volume one, but if you click here on help, taking help with the screenshot, and it won't let me do it here because I'm in the edit mode. But when you're in Microsoft, I think you can hit the Windows and S. Nope, that wasn't it. Windows Shift and S. Yeah, there you go. And that opens the snippet tool. And so you highlight on the screen what you want to take a snippet of and then let go. And so it takes a little snippet for you. And then what you do is you go into the Go Formative and it'll say right here for you, it'll hit submit, show your work. It'll say show your work. And so you click on this button here for show your work, and then you can paste your image here by going Control V. And it'll put your screenshot in there for you. You don't want to save a lot of screenshots onto your desktop because your laptop wasn't bought with a large amount of RAM on it. And so you want to, if you're going to save your screenshots, you need to save them to your OneDrive. I would suggest if you use OneDrive to make a folder called Physical Science so that you can start putting your images there. When you do it this way, it puts it on your clipboard, you can paste it into the formative, and then you don't have to save it. Okay, so that is the must do. And then you have a should do called Fun Brain Measure It. Same thing as a game on measuring length. So that's a should do. You don't have to do it, but it will help you review and practice measuring length. The next measurement we're going to talk about is volume. And volume is the amount of space something takes up. When we talked about my coffee cup, we talked about how many milliliters were in my coffee cup. Now there's about 5 less. So how much space something takes up. The base unit for volume is a liter. And when we determine volume for regular solids, I'm sure you remember these formulas from your math class. So if I wanted to find the volume of a cube, I would measure the length and cube it. Take it times itself 3 times. We can also measure volume using a graduated cylinder. And when you use a graduated cylinder, you're going to measure the bottom of the meniscus. So the meniscus is this area right here, the bottom of this curve. And what happens is water is more attracted to the sides of the graduated cylinder than it is to the next water molecule. And so it pulls up on the sides a little bit. So here's where you're going to measure. So here's an example. What would the measurement on this graduated cylinder be? And so we know that it's more than 6 milliliters. And we know that it's less than 8 and it's less than 7 milliliters. Oh, here's my 7 line. So then we got to figure out how much do the little lines equal? And so we got 1, 2, 3, 4, 5 in between. And so 1 milliliter divided by 5 gives us 0.2 milliliters. So then we look at our measurement again. Somehow my screen pushed off the measurements. This should be up here. So the bottom of the meniscus is right here. And so 6.6 would be a good measurement. Meniscus. That's a vocabulary word. Your must-do for measuring volume is an interactive, and it has noise, so you're going to want to put on your headphones. And just like the previous interactive, you're going to submit your work. So let's see if I have it pulled up and we can look at it real quick. So it's going to look like this. You hit play. And then as you go through, it's going to ask you measurements, and you're going to put in your screenshots of the practice volumes on the interactive. So this one is practice 2. And so you would take your screenshot where it says correct, and see how I blurred out the correct answer in the example. And so here it would say, show your work. You'd hit that button, and then you're going to control paste your screenshot there. Remember, there's this help with taking screenshots here if you forget how to make a screenshot. So that's the must do. And then there's a should do. Gizmos are an interactive website that the district has purchased an account for you. And it's fun little interactives. What you do is you go to ClassLink. So here I have ClassLink open, and I can never find it when I'm like searching through all the apps I have. It's down in science for me. My computer never wants to be nice to me. Where is the science folder? So here in my science folder, and it's this little light bulb right here, but I can never find it when I need it. So what I'm going to do is I will pull this down here so you can see. Maybe, maybe not. Is up in this search bar, I'm going to type Gizmos. And there that app pops up for you. Okay, I don't have anything here because I don't have any students on my roster yet. But when you log in, you'll see something there, and you'll see our class, and you'll have assignments in there. So I'm going to go here. And see if I can try the free version for a minute. So in this gizmo, gizmos usually have one window, which is your interactive window. And so I have a beaker I can use. I have graduated cylinders I can use. I can put a beaker back up here in my tools. I can grab a ruler if I want it. I have some objects I'm going to measure. And so you start out in free exploration, and then as you go through the gizmo worksheet, it's going to tell you what to do. It's going to say, take the beaker and fill it with 20 milliliters, and then add the rock. It'll tell you what to do. So you hit practice there, and it will give you some activities. With each gizmo, if you scroll down, there's one thing you have to do at the end that's required, and that's the assessment questions. So if you pull up the interactive window, it won't let me in. But if you were logged in, it would have 5 to 10 questions underneath here to test your understanding of what you did in the gizmo. So always remember that when you finish, to pull up the interactive video and do the assessment questions that are here. And then we have mass. Mass is anything that has matter and takes up space. The base unit for mass is a gram. We can have kilograms, centigrams, milligrams, nanograms, picograms. And so grams is the base unit. A paperclip weighs about a gram. So if you were, wanting to be Einstein at home, you can say, find me something that that has the mass of a gram. And so the must-do activity that you need to do is an interactive called Reading a Triple Beam Balance. And you need your headphones again for this one. It has sound. And I don't know if it has a go formative or not. Yeah, I think it does. At the end, you have to show your certificate of finishing.
To measuring volume using a graduated cylinder. Graduated.
Whoopsie. Computer is unhappy. And so here's that interactive. And it tells you what you need to take the clip for. And then you'll hit show your work down here and put in your clip of your correct answer. Notice I blurred it out in the example. Oops. All my things are right here together. So, okay, I'll just leave it for now. So that's the must do. And then the should do is, again, a gizmo, reading a triple beam balance. Let's see if my page for gizmos is still, didn't want that one. That's the go formative. Okay, we'll just try this. Again, I can't log on right now because it's summer and there's no students attached to my account. And so here you have the interactive part. And you can put objects on the balance. You can move the sliders. Over here, it's going to blow up this area of the triple beam balance for you. And so you will move the sliders. You got the 100 slider, you got the 10 slider, and the 1 slider. And again, the gizmo will tell you what to do. It'll say, put the red object on the pan, move the blah, 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 blah. Okay, so that's the should do. And you'll have a worksheet that goes along with it. It'll be in your Unit 0 packet. And then we have to talk about something really quick. And it's this misconception that most people have that mass and weight are the same. And they're not. They're different. Weight is how much is gravity pulling on a mass. Mass is how much matter is in an object. So an example here is a pineapple. A pineapple is about 1 kilogram. It's going to have the mass of 1 kilogram, whether it's on the moon, Jupiter, Saturn, Earth, but it's going to weigh different on those different planets, those different locations, because of the pull of gravity. The moon is smaller, has less mass, and has less of a gravity to pull on a mass pull on a mass. So if the pineapple was on the moon, about 1/6 of the pull of Earth would be on that pineapple. So it would weigh less on the moon. It would weigh 1.62 newtons. Newtons is a measurement of force, and weight is a force. It is the amount of gravity pulling on a mass. Versus Jupiter, Jupiter's a lot more massive than Earth, and it would have a stronger gravity pull. And so this pineapple would weigh 24.76 newtons. So mass stays the same no matter where you're at, because it's the amount of mass in an object. That doesn't change. But weight depends on gravity, and gravity depends on your location. So weight and gravity are not the same thing. A lot of people get them mixed up.